Hey guys, just thought to make a simple video on static electricity. Okay, over here you see three items. We've got a woolen jacket, a balloon here, as well as a wall. Okay, one thing you see in common among all these three items is that they are actually all neutrally charged. Okay, what do I mean by that? Okay, it means for every single, you can see there's the red color positive charge. For every single positive charge, there is a corresponding negative charge. Okay, so you can see same for the wall as well as the jacket. So there's actually no attraction or repulsion that you can actually see currently. Okay, next I'm going to just do something. I'm just going to bring my balloon over to my woolen jacket and just rub it a little bit. Oh, do you see something? Wow, that's right. As I rub it more, you can see more of these negative charges from the jacket actually gets transferred over to my balloon. Okay, let's see whether can I get more of it. And whoa, check this out, man. I can actually get every single negative charge out of my jacket and get it transferred into my balloon. And oh, notice something else here? If I let go of my balloon halfway, what happens? It gets attracted to my jacket, right? Okay, how does that happen? Okay, why does it happen? Okay, so that's why the first law that you see in static electricity is you can see here my jacket is right now net there's a resultant positive charge only on the jackets. And what about the balloon? Correct. That's right. Balloon is resultant negative because there are more negative charges than positive, right? So if I were to put negative charges near positive charges, guess what happens? And boom, you're right. It gets attracted. So our first law, we will know that opposite charges, unlike charges, will attract. Okay, one more thing, just want to show you. Just look at the wall here. Look at the charges on the wall, and you notice anything? You can't really see it right now, but very soon, and whoa, you see that? As I move closer, and whoa, can you see that? As I move closer, and can you guess what's happening here? Okay, my balloon being net negative, resultant negative charges, as it goes near the wall, it actually repels the negative charges. That's right. Okay, so first thing that we found out here was that unlike charges, negative and positive will attract. Negative in the balloon, positive in the jacket. And the second thing that we notice is that like charges, that means negative on the balloon, and the negative charges in the wall will repel. Okay, there's one more thing that I just want to show you in this simulation, which I'm sure you probably noticed. Okay, when I just reset this, okay, if I move, rub the balloon, you can see what are the only charges that move. Do my positive charges actually move? Even here? No, my positive charges don't get transferred or moved at all. Only negative charges, right? Okay. Okay, so just to recap how do positive and negative charges actually interact. Just now we mentioned like charges always repel. Okay, so if they are like, whether it is negative negative or positive positive, doesn't matter, as long as they are alike, it will always repel. And the opposites also will be unlike charges. So if they are positive, one is positive, one is negative, they will always attract to each other. Okay. All right, so what are electric charges? Okay, as you know, atoms only consist of three main things: neutrons, protons, and electrons. Okay, so if I remove electrons, my atom becomes positive charge. Okay, because electrons removed, they're only left with positive, either only left positive charges or they have a resultant that's positive. So that means there are more positive charges than negative charges, right? Okay, so the opposite will be if I add electrons, what will happen? The atom will become negative charge. Okay, remember the start of my simulation, what happened? Okay, when the number of electrons is the same as the number of protons, my atom is neutral. Okay, all right, so measuring electric charges. Okay, how do we measure? SI unit for electric charge is the coulomb. Just to give you an idea of how much is one coulomb, 1 coulomb, the amount of charge carried by an electron is actually 1.6 times 10 to the power minus 19 coulombs. Okay, what does this mean? That means 1 coulomb of charge actually contains this amount of electrons. So that's a large number of electrons, right? Okay, what does it mean? It basically just means that one electron constitutes a very, very small charge. That's why we cannot measure in terms of the number of electrons. We got to use an SI unit that is has a big enough amount of electrons so that we are able to measure it better. All right. Okay, with that, hope you enjoyed this video, this introduction to static electricity. I'll see you guys in the next.